Hello and welcome to another session in mathematics. In this session, we'll still be looking at circle. But before that, let us take a review of our previous lesson. Welcome back. In today's lesson, our focus will be on tangents and angles in the alternate segment of a circle. Tangent and angles in the alternate segment of a circle. So, a tangent to a circle is a straight line which touches the circle at one point only. The tangent touches the circle but does not cut the circle. Okay, when we have a straight line and then there is a circle that touches this line. Okay, and then we'll have a straight line where this is the center, let's say O, and here is X, this is Y. Okay, and let's call here T. Let's assume here is T. Now the line XY is said to be what? To be tangent to the circle at point T. The line SY is said to be what? Tangent to this circle at the point T, which is here. Okay, with what? O. So this line is what we call the tangent. And then the line OT is the radius, remember, of the circle. Okay, so we've now understood what a tangent means. So let us look at the theorems of these tangents. Okay, the first theorem, he said a tangent is perpendicular to the radius at the point of contact. The tangent is what? Is perpendicular to the radius at the point of what? Contact. Okay, we have this. Let us see. When we bisect this, what do we have? We have angle 90. This is our center. Let's call it O, and this is our X. This is our Y. This is our T. Now, you agree with me that line OT is perpendicular to what? XTY. This is XTY. Okay, line OT bisects this XY. That's what we mean by perpendicular. Perpendicular means what? It bisects it, okay, into two parts. Now the line OT bisects what? Line XTY. Okay, and then looking at this figure, you will also agree with me that angle at T is equal to the angle at T when it comes to line OTY, and it is 90 degrees. What do I mean? This is OTX. The angle here is also 90 degrees. Is that correct? And then the angle when it comes to OTY is the same thing, and it is also what? 90 degrees. Do we understand now? So we say that the tangent is perpendicular to the radius at the point of what? Contact. That is this. So the radius bisects this what? Tangent. Okay, let us look at the second theorem, theory 2. It says the tangent to a circle from an external point are equal in length. They are equal in length. The tangents to a circle from an external point are equal in length. Okay, let us illustrate that. We have a circle, and we have this. Then we have this. We have this joining this here. We have this joining this here. Okay, now you agree with me that these two lines are equal. Okay, then we have let's take here to be O, call here A, take here to be B, and let's say that here is T. Okay, looking at this diagram, you agree with me that line TA is equal to line TB. TA, this line, is equal to this line. Is it correct? Then also angle ATO is equal to angle BTO. This is angle ATO. Okay, angle here, the angle here, let's take it to be, let's say theta. Okay, is also equal to what? Angle BTO. Okay, this is also equal to this. So these two angles are what? Are equal. Okay, that's number 2. Then line OT bisects line AB. Line OT, this is our OT, bisects what? Line AB. Okay, so at that point we said that the tangent to a circle from an external point are equal. These two lines are equal. The angles here are equal. Okay, theory 3, we have the third theorem. It said the angle between a tangent to a circle and a chord through the point of contact is equal to the angle in the alternate segment. The angle between a tangent to a circle and a chord through the point of contact is equal to the angle in the alternate segment. Okay, what do we mean by this? Let's illustrate that. We also have a circle. We have this. Then we have this. We have this. Let's take here to be B, and this is A. Now we have our tangent. Then we have this, and then we have this. This is B, and this is A. This is X, T, Y. Okay, look at what this theorem states. Let's take it to be A, and this is B. The theorem states that a tangent to a circle and a chord through the point of contact is equal to the angle in the alternate what? Segment. Look at what it's saying. Looking at the angle here, we have triangle TAB. We have triangle T, A, and what? B. Is that correct? And this triangle TAB is alternate. It's alternate to triangle BTY. BTY. Okay, it's alternate to what? Triangle BTY, which is BT and what? Y. Now, it means that TBA is alternate. It's alternate to triangle ATX. This is triangle ATX. Okay, triangle TAB is alternate to triangle BTY, and then triangle TBA is alternate to what? Triangle ATX. Do you understand? Okay, then it means that angle at TAB, angle at A in triangle TAB is equal to angle at T in triangle BTY. Okay, since this is alternate to this, and then this is alternate to this, then angle at A in this triangle is equal to the angle at T in this triangle. And similarly, angle at B in triangle TBA is equal to angle at T in triangle ATS. Okay, so that's exactly what we want to prove here in this theorem. Okay, so let us quickly take an example to illustrate these theorems better. Question number 1. Calculate the value of the lettered angles in the following figures. This is the first figure, figure 1. It said 0 is the center of the circle. Okay, we have here, this is the center of the circle. We have here to be 56. Here is theta. This is our A and this is our T. Okay, let us start. Looking at this triangle, you agree with me that here at this point is angle 90. So we say that OTA is equal to 90 degrees. True or false? This is a right angle triangle, so here is angle 90. Now the angle at A, which will now give us theta, that's the value here, theta is then equal to angle 180 minus 90 degree plus 56 degree. So we have theta to be equal to 180 minus 90 plus 56 will give us 146. Is that correct? And then if we subtract that, theta will then be equal to 180 minus 146 will give us 34 degrees. And that's that. As simple as that. Example number 2, we are asked to find the letters in this diagram. We are asked to find the letters here in this diagram. Okay, let us start. Looking at this diagram, you will agree with me that P, letter P, which is here, is equal to 90 degrees. And we call it what? Angle at the semicircle. Angle at the semicircle. Angle at semicircle is equal to 90 degrees. And then you will agree with me that X is equal to 180 degree minus 55 plus 90. Okay, so we have X to be equal to 180 minus 145, and that will give us what? 35 degree. That's the value of X. Okay, now we have Q here. What's the value of Q? Q is equal to 90 degree. That's the value of the tangent is perpendicular. Okay, so our Q is what? Is 90 degree. Okay, then we have X plus Y to be equal to what? 90 degree. X plus Y is equal to 90 degree. Since the angle here is equal to 180, angle on a straight line, is that correct? X plus Y plus Z will give us what? 180. And remember, Q already is 90, so X plus Y is equal to 90. Now we've gotten the value of X before to be 35, so Y will be equal to 90 minus what? 35, which is equal to 90 minus 35. What do we have? We have what? 55 degree. So our X is 35, our Y is 55, our P is 90, and our Q is 90 degree. Okay, so thank you for joining us in today's class. We'll stop here today, but to refresh our memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. We've been able to deal with tangents and angles in the alternate segment of a circle, and we've taken some examples and their theorem. We'll stop here today, so do well to use the lesson note on the platform for better information on what we've done so far, and feel free to leave a comment or question on the comment section. Until we meet again in our next class, stay safe and bye.